Hey guys, this is John Wynn from Immunology class. Today I want to talk about monoclonal antibodies, abbreviated MAB. What are they and why are they important to medicine? Before we begin, actually, there was a special issue of Science magazine last month that covered monoclonal antibodies, and I think you guys should check it out. You can find it at the library at MCBHS or stop by Professor Demasi's office. It's very interesting. It talks about how the advent of these so-called magic bullets gave rise to modern therapeutics and diagnostics, and definitely check it out. Alright, so what is a monoclonal antibody? Well, from the name, you probably may guess that it's a kind of antibody. And you're right, they are antibodies, but what makes them special is the fact that they all originate from a single hybrid cell line called a hybridoma. These hybridomas are basically fusions between antibody producing B cells and myelomas, which are cancerous plasma cells. These cells are immortal, and they've also lost their ability to synthesize new antibody chains, preventing variation and allowing a high degree of specificity. In contrast, polyclonal antibodies, as you can tell by its name, are secreted by different B cell lineages, and thus have multiple corresponding epitopes or binding sites found on antigens. This specific binding affinity confers an advantageous feature in monoclonal antibody drug therapy. Because they are so specific, they may only have mild side effects, unlike other treatments. Monoclonal antibodies are like any other antibodies we've learned in class so far. They're only special because they have a really high specificity, and they also are secreted by hybridomas rather than normal B cells. But they function pretty much the same as any other antibodies. They make pathogens more visible to the immune system, and they do this by initiating the classical pathway of complement activation, neutralization, opsonization, something we've learned already. They also block receptors that interfere with communication. They can also intercept signals that prevents cancerous cells from recruiting blood vessels. What else? They also deliver radiation. These are actually very special monoclonal antibodies because there's actually two subtypes. Actually, there's more, but we'll talk about two for now. There's the conjugated monoclonal antibodies, and there's the naked monoclonal antibodies. The conjugated MABs are actually just regular MABs attached to a radioactive substance, a drug or a toxin, just another element that enhances the therapy. But for now, we'll just focus on just the naked monoclonal antibodies, just the antibodies itself. In 1986, the first monoclonal antibody drug was approved by the FDA. It was called moraminab, and you can tell that it's a monoclonal antibody drug because it ends in AB, probably standing for antibody. Its epitope was the CD3 antigen on human T cells because it was used to prevent transplant rejection. This blocking of the T cell response prevents the T cell mediated rejection of the transplanted organ, specifically kidneys. Since then, over 30 monoclonal antibodies have been approved by the FDA, and many more are in clinical trials at the moment. Scientists have created other monoclonal antibody drug therapies for other diseases such as Crohn's disease, psoriasis, and even breast cancer. Monoclonal antibodies play a very important role in the development of vaccines, specifically HIV. And we'll talk more about these specific therapies in the future, but to wrap it up, let's talk about moraminab. It's the drug that treated transplant rejection, as we talked about before. Moraminab is actually derived from mouse antisera. Murine C regions of the antibody, murine being a word from the Latin murinus or mouse, these C regions or constant regions diminish efficacy of the drug and also increase the likelihood of complications. Now, this problem prompted scientists to make a chimeric monoclonal antibody that combined both mouse variable regions and also human C regions, and this increased efficacy greatly. There's another kind of MAB called humanized monoclonal antibody, and we'll talk more about these and the differences between these three, murine, chimeric, and humanized, in future videos. So that wraps it up for the introduction to monoclonal antibodies. Thanks again for watching. Yeah, you now know what MABs are and why they are so important in medicine. I hope this was useful to you. And anyways, next time we'll talk more about the production of monoclonal antibodies and how they're created. Thanks.